Hello, welcome to FNRM 3131 and 5131, the gateway courses to GIS here in the College of Natural Resources at the University of Minnesota. We teach these courses because spatial problems are pretty much unavoidable in natural resource management and in lots of other fields. And so this is the basic introduction to get your feet wet in doing spatial analysis. Now it's a soup to nuts course. We start at the very beginning with how we put data together and how we talk about spatial data all the way through producing analysis and results that might give you actual information. Now there's upwards of 50 courses in GIS or in spatial analysis here at the University of Minnesota. There's another good parallel intro course over in the Department of Geography. Either of these two courses are interchangeable. You'll have a similar set of skills, and then you can build on these courses. Lots of things we're going to introduce and that not cover in depth. A few things we'll cover in depth. This is just the first stepping stone on a path that will allow you, if you wish, to really delve into spatial analysis. But hopefully it'll teach you an appreciation and useful tools that you can apply in other courses or in your careers, even if you're not a spatial analysis specialist. So the objective for today is to go through the content, motivation, mechanics, and grading. And I'll break these up into small videos. So this video will end, but there'll be other videos to watch for the first day. We're also giving this presentation in public. All these videos together basically covering the same information we'll do in a public presentation each week that students can attend if you're signed up for the online or the in-person course. We also have space to answer questions during those lectures. So the idea is to try and meet as many learning methods as possible for the most comfortable sort of learning environment that different students find. Now, in Bloom's taxonomy of learning, and we're aware of all its limitations, we're really here at the very base, the knowledge comprehension and application, some into the analysis. You won't expect to be able to do much synthesis after this introductory course. We want to introduce the basic way of thinking about spatial data and have you understand how things are structured and be able to do the most basic of applications. But there's a lot of work between even now and then, and really building on that third, fourth, fifth, and sixth steps of the skills is what you would do in future courses. There's a lot we throw at you. It's organized in the basic course page here shown for 5130, and it'll be basically the structure slightly different. So we have the syllabus and Canvas access and a lab page, and then information here on how to do the mechanics. Now, the current one is a little bit different than this. We have more here because we've developed a system whereby you don't have to load the software on your home computer, but rather access it through a virtual machine in any web browser, although there are a few preferred web browsers. So we have information there that is also covered in the course web page pretty systematically to help you get going to load up the system so you can work. The readings from the book, actually, it'll be the 6th or 7th edition that's required. You'll see that on the course web page, access through the Canvas site and through this course web page. And it's GIS Fundamentals, a book I wrote 20 years ago now. It's used at about 400 universities across the country, actually across the world. And then there are the videos here with supplemental information, the lab assignment that you access through the lab page, and then a quick description of what you have to turn in. And this is organized then week by week in each row. If you go to the lab page, it shows you all the information you have here for the lab. So an introductory video for the week that makes sense if there is a need for one, then lab instructions, summary, and helpful videos for sections of the lab, 2 to 10-minute videos that show how to go through particularly tricky uses of the software, data to download that you need for the week's lab shown there. Now, the class mechanics, every week you need to do readings for both the lecture and the labs. Now, the readings in the textbook are generally 30 to 50 pages that underpin what you're doing. You can do the labs and work through them without paying attention to the readings, but you won't understand what you're doing, and it won't help in learning the material both practically and for the exams in the long run. If you don't focus on the readings, you're not going to get 50% of what you should out of this course. Again, as I said, lecture participation is optional after this first week. The first half of the period will be on the high points of the readings and the ideas that we're trying to cover, and then we'll focus on questions and working examples. There's a quiz every week that's due the Monday of that week before the first lecture starts. So these weekly quizzes are to make sure you've done the reading. If you've done the reading, you basically will be able to get 90% on these quizzes or better. They're typically 5-6 questions. And so the quizzes really just try and spur you to make sure you've done the readings and thought about them. All told, the quizzes are worth about half, 2/3 of an exam, so they're important enough to do, but not so important that if you miss a question, you need to worry too much about it. They're weekly lab exercises, a couple of homeworks, and for the graduate students, a 4-part semester-long exercises. There are also 5 exams, 4 exams, and then a final. And you turn all this material in to do all this material through Canvas. There's a Canvas page that you access, but we're using the Canvas page mostly just to turn things in. Now, the lab mechanics allowed to do Friday night at 11:55 on Canvas, a week after assignment. Our labs are up to 1 week late. They're penalized 33%. So try and get something in. And labs more than a week late, we won't accept just because it's hard to go back and do the grading. Now, if there's an extenuating circumstance, like you're ill or have some major crisis, then don't worry about this. Get back to us. It would be good if you could arrange scheduling difficulties in advance. You know you're going to be out of town at a wedding or something that you can plan. Please let us know, because we're a lot more lenient if you let us know in advance. It's a straight grading scale. You aren't competing against other folks. It's more sort of a mastery rather than a competition kind of view. And so you basically get an A+, though it doesn't mean anything if you're greater than 100%. You might ask, how can I get over 100%? Well, there's extra credit, and a few people each year do all that. 90 to 100 is an A. We don't give A minuses for the 90 to 92.5 because that dinks your grade point average, whereas an A+ doesn't give you a 4.3 or some other thing. So we kind of think that's unfair. And you can look along and see what you need in terms of points. Again, the points are from the weekly reading quizzes, the weekly lab assignments. You can get their relative weights here, the 2 homeworks, the semester-long projects, lectures, the 5 exams, except that the final exam is worth double what the regular exams. This is exactly true. It's 90 points, so 4 for the regular exams, and then 45 for the 4 regular exams, and 90 for the 5 exams. And then there's an extra credit lab worth about 35 points total. So that's a quick overview of the mechanics. Andy will also be providing a specific video talking about loading the software and getting the specific things done. And you can find those then on the course main page or the lab page.